So in this video, we're going to be finding every possible rational root of a polynomial function, and we're still going to be using things like the rational root theorem and synthetic division. But this time around, we're going to use another strategy to help us with the rational root theorem. If we have too many roots, how can we actually narrow it down and start to kind of take educated guesses on what these roots might be so we don't have to test 20 different roots or something like that. So we're going to look at other possibilities of things we can use to help us to kind of hone in on what those rational roots might actually be.
So here we have our polynomial function. And remember, to start off these problems, we start by looking at our a sub 0 value, which is 12, and our a sub n value, which is our leading coefficient, which is 10. And we're going to find every single possible factor of those two numbers. So for 12, I have 1, 2, 3, 4, 6, and 12. And for 10, I have 1, 2, 5, and 10. So what we need to do is we need to pair up every single factor of a sub 0. So these are all of my p-values. And I need to pair them up with all of my q-values and make a list of possible factors. So I'm going to make a list here of possible factors. So we're just going to go through and we're going to pair up each one. So I'm going to start with 1 and 1. So if I do 1 over 1, that is just 1. I then take 2 over 1, which is 2, 3 over 1, which is 3, 4 over 1, which is 4, 6 over 1, which is 6, and 12 over 1, which is 12. And then I move on to the 2's. So now I'm focusing on this q value of 2. So I start with 1 over 2, which doesn't simplify any further. It's just 1 over 2. I then take 2 over 2, which becomes 1, which is a repeat of another value, so I can ignore that one. I then take 3 over 2, which stays 3 over 2, doesn't simplify further. I then take 4 over 2, which simplifies to 2 and is a repeat of a previous number. I then take 6 over 2, which is equal to 3 and is a repeat of a previous number. And then I take 12 over 2, which is 6, and is a repeat of a previous number. Then I move on to the next q value, which is 5. So I take 1 over 5, which doesn't simplify further. Then we have 2 over 5, which also doesn't simplify further. 3 over 5 doesn't simplify further either. Neither does 4 over 5. 6 over 5, or 12 over 5. So none of those simplify further. They're just left as the fractions that they are. Finally, we take our q value of 10. So we have 1 over 10, and that one doesn't simplify any further. We then have 2 over 10, which simplifies to 1/5 and is a repeated value, so we can cross it off. We then have 3 over 10, which again is a fraction that doesn't simplify further. We then have 4 over 10, which simplifies to 2/5 and is a repeated number, so we can cross that one off. We then have 6 over 10, which becomes and simplifies to 3 over 5, which is a repeated number. And then we also have 12 over 10, which simplifies to 6 over 5 and is also a repeated number. So I can see in here I have a number of possible factors, and so I'm going to make my final list here, including all of the pluses and minuses. So I have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, plus or minus 1/2, plus or minus 3/2, plus or minus 1/5, 2/5, 3/5, 4/5, 6/5, 12/5, and then 1/10 and 3/10. So I have quite a few options here for numbers that could become possible zeros.
And while yes, we could go through, use synthetic division on all of these, and try to find exactly which ones work and which ones result in our rational roots, because of the high number of roots that we have here, this could take a really long time. So on the next slide, what we're going to do instead is we're actually going to use the graph of this function and a visual representation of it to help us narrow down which of these roots might be actual roots for this particular function.
So what I've now done is I've listed out all of my possible zeros here, and I've created an accurate graph of this particular situation. Now, I suggest if you do not have a graphing calculator that one, you borrow a graphing calculator in class, or two, if you're at home, you utilize the graphing website Desmos. So that's how you can get an accurate graph. You're going to want to be able to see the accurate graph here because you're going to have to use this accurate graph to make a prediction about which zeros or x-intercepts are actual possibilities, because to guess out of all of these options would take an insanely long time to figure out which ones are right. So if I take a look at this graph, what I notice is I have 1, 2, 3, 4 zeros. So I have 4 different numbers I'm looking for. And some of those possible numbers lie in this list. So I'm going to use what I see in the graph to guesstimate what one might be and then test it out to see if it is in fact a factor by utilizing synthetic division. So if I look here, this first zero, this one looks like it's about -1/2, which is the fraction -3/2. And I can see that that is an option here. So what I'm going to do is I'm going to utilize synthetic division to check and see if this is in fact a factor. Because if it is a factor, what's going to happen is I'm going to end up with a synthetic division that has a remainder of 0. So we're going to go ahead and give that a try. So we have -3/2, and then we're going to utilize these numbers here. So I have 10, -11, -42, 7, and 12. So I bring down the 10 here. 10 times -3/2 becomes -30/2, which is a -15. We add straight down, that's -26. Then we multiply -26 by -3/2. That becomes -3 times -26 is 78/2. So that's a +39. Add straight down, that's -3. So then we multiply -3 times -3/2, which becomes a +9/2. So now that I no longer have integers, I do have to convert these a little bit. So this becomes 14/2. So if I add those straight down together, I get 23/2. And then I multiply that by -3/2, which becomes a -69/4. Well, I convert the 12, that becomes 48/4. So I end up with a remainder of -21/4. So because I have this remainder here, that tells me that -3/2 is not one of my zeros, which is kind of a bummer. I was really hoping it was. So since that one is not the case, what we're going to do is we're going to move on to the next one. We're going to focus on this one. And this one looks like it might be a -1/2. So what we're going to do is we're going to try that one out second. So we're going to try out -1/2 and see what happens. So we have 10, -11, -42, 7, and 12. So if we utilize synthetic division, we drop the 10 down, multiply that by -1/2, that's -5, add straight down, that's -16, multiply -16 by -1/2, that is +8, add straight down, and that becomes a -34, multiply that by a -1/2, and that becomes a +17. I then add straight down here and I end up with 24. 24 times a negative 1/2 is a negative 12. Add straight down and I get 0. So what this tells me is that negative 1/2 is in fact a factor. So what I can do here is I can rewrite this polynomial to be x plus 1/2, because remember it's the opposite of what this is. So that's what I have as my factor, x plus 1/2. And I can then include this next part here. So this was my remainder. So this is my constant, my x squared, and my x cubed. So I have 10x cubed minus 16x squared minus 34x plus 24. So I've now found one of my 4 factors. So better than nothing, but not quite done. So now I'm going to have to test out another one because I'm not quite done. And I'm going to start from this piece right here and focus on finding another factor of that 10x cubed minus 16x squared minus 34x plus 24. So I'm going to move on to this point right here. And to me, this one looks like it's a positive 1/2. So we're going to test that out and see if that is in fact a 0. So we're going to give ourselves a little space here. And then I'm just going to scroll up just a bit so I have a little bit of writing room. There we go. So I'm going to test out that positive 1/2 using synthetic division. And again, I'm going to utilize this polynomial here that is left after my first synthetic division. So I have a positive 1/2 this time. And then I have 10, negative 16, negative 34, and 24. So I drop that down. 10 times 1/2 is 5. Add straight down, that's negative 11. Times 1/2, that becomes a negative 11 over 2. We then have to convert this one into halves. So that becomes a negative 68 over 2. So we're going to add the 2 together. We get negative 79 over 2. We then multiply that by 1/2, which becomes negative 79 over 4. If we convert this, this becomes 96 over 4. So if we add the 2 together, we end up with a remainder of 17 over 4, which we can see is not going to be helpful. So it looks like it's a positive 1/2. It's not. This is not a factor, just like the negative 3/2 was not a factor. So what I'm going to try here instead is I'm going to see if there's another number that is close to this. Is there another number in my list that is close to it? And what I notice is that another number that is close to it is a positive 3/5. That turns into about 0.6. So I'm going to test that one out just to make sure that it's not the value before I move on. So here we take 3/5. We're going to do the same thing. We have 10, negative 16, negative 34, and 24. So we drop the 10 down, and we multiply it by 3/5, so that becomes 30 over 5, which is 6. We then add straight down, that's negative 10. Negative 10 times 3/5 becomes negative 30 over 5, which is negative 6. We add straight down, so we end up here with negative 40. So we have negative 40 times 3/5, which becomes negative 120 over 5, which is a negative 24. And if we add straight down, that becomes 0. So what we find is that this 3/5 is in fact a factor, which is great. So we now have 2 factors. We have negative 1/2 and a positive 3/5. So what we can do is we can update our equation here. So we have x plus 1/2. We then have x minus 3/5, because remember it's opposite our k value. And then we can write this as 10. This is our x squared, our x, and our constant. So we have 10x squared minus 10x minus 40. So what I'm going to do here is I'm going to try and see if I can figure out what this last 0 is here. We knew that this one we're going to have to find in a different way. But maybe we can find this 0 here. And this one to me looks like 1.5. So I'm going to test out 3/2 and just make sure that it is not a 0. So I want to test it out. Even though this one didn't work out, maybe the one on the right will. So if I take a positive 3/2 and I use synthetic division on this last part here, we have 10, -10, and -40. Well, 10 times 3/2 becomes 30/2, which is 15. We then add straight down, that's -5. -5 times 3/2 is -15/2. If we convert this one, it becomes -80/2. So I have a remainder of -95/2. So what I know for a fact is that this 3/2 does not work. So I have utilized this list up here to the max. I have found two that work in -1/2 and a positive 3/5, but I haven't been able to find the other two. So what that means is I'm probably going to have to use a quadratic solving strategy to solve this. So I'm going to move this up to give myself more room, and I'm just going to translate my current factored form or polynomial equation down here. So currently I have f of x is equal to x plus 1/2, then x minus 3/2. So that accounts for those two values I found in -1/2 and positive 3/5. And then I have 10x squared minus 10x minus 40. And what I'm going to attempt to do here is I'm going to attempt to solve this utilizing a different strategy. So if I think through all of my quadratic solving strategies here, I think through the fact that I could use factoring, but let's see, if I try to use factoring here, if I factor out a 10, which I know I can do, I end up with x squared minus 1x minus 4. But unfortunately, I don't know of any numbers that multiply to be -4 and add to be -1. So I can't use factoring here, but what I can do is with this trinomial left, I can utilize the quadratic formula. So while factoring won't work, the quadratic formula will work on that. Remember, that's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So if I substitute my values in there, I do x equals opposite of b, which is 1, plus or minus the square root of -1 squared minus 4 times a, which is 1, times c, which is -4. You can utilize keep, change here if you want. All over 2 times our a value of 1. So then we end up with 1 plus or minus the square root of 17, all divided by 2. So what we actually find here are two additional solutions here. We find that x is equal to 1 plus the square root of 17 over 2. We find that x is equal to 1 minus the square root of 17 over 2. So those are two possibilities. And then we have the -1/2 and the positive 3/5. So we're able to find all our four answers by utilizing our knowledge of the rational root theorem and testing out which ones work using synthetic division, and our quadratic solving strategies including factoring, quadratic formula, any of those. So here are our four solutions, or our four zeros, to our polynomial function.